And welcome to the Daily Space Weather. I'm your host, Dan, aka smAsho. And what we're looking at here is 304 angstroms, part of the UV spectrum, ultraviolet light, coming from ionized helium on the surface of the closest star. And just a quick little tidbit of information about this. Why is it that the sun looks so differently in helium emission spectra than it does in other types of emission spectra? So this is 304 angstroms, a very specific band of ultraviolet light associated with ionized helium. It's vibrating very quickly. Why does it look so differently when we look at it under ionized iron? So here's one of the many ionized states of iron that we see on the surface of the sun. This is 193 angstroms. Why does it look so differently? Why does the iron orient itself in such a different dynamic series of chaotic patterns as opposed to the way helium does? Is this telling us about the internal structures of the sun? Well, certainly it is. Some coronal holes rotating in, and we're about to see a geomagnetic storm once again from another coronal mass ejection, one which we forecasted before it left the corona. And we're also expecting a coronal hole wind stream in a couple days from this series of coronal holes associated with the south solar polar region. And back to the different ionized states, here's 94 angstroms, another ionized state of iron. It's very, very hot gaseous plasma made of iron. And you can see how differently that looks compared to another ionized state of iron. So 193 angstroms and 94 angstroms are both ionized iron. See how differently they look. And see how differently they look as compared to ionized helium. The sun is jumping up and down and saying, "Look at me. I'm telling you things about physics." Now, there is a coronal mass ejection apparently propagating once again as we make the video today, so let's take a look at the perspective from stereo A, located out here at Lagrangian point 5. It could be another Earth-facing, Earth-directed coronal mass ejection. We'll have to look at it later in the day to get a definitive answer on that. But here's what's going on currently from the perspective of stereo A. So when you look at the sun from stereo A, Earth would be off to your right. And it looks like we see some plasma in the process of ejecting, both on the far side and the near side of the sun here. So right at the end of this little run here, you'll see it could be a filamentary collapse as well, folks. So we'll have to, I'm about 50-50 on whether that's an ejection or a collapse. I would say the most likely spot for an ejection is the far side of the sun, but that can destabilize the portion facing the Earth as well. So in any case, it's something to keep an eye on. Also, here's a colorized magnetogram, which is probably the easiest way to look for sunspots. Check out the colorized magnetogram. It shows you the North Pole solar polar field polarity in green and blue if it's a full sunspot, and the South solar polar field polarity in yellow and red if it's a full sunspot. And we've only got one right now, sunspot 2822, which has degraded since yesterday to an alpha class sunspot. Here's a diagram of the solar system. We show it daily to give people a perspective. And there's where things will be in a week. We'll be approaching another full moon. And we're over halfway through spring, and I figured I would bring up the solstice countdown. We will be streaming live, probably on YouTube and on Twitch at the moment of the solstice, just over a month away. You can find your countdown timer for your solstice at timeanddate.com. Here's a star chart. We show this daily as well. We've got Jupiter and Saturn near the apex of the ecliptic from my location. Perhaps put in your own location if you'd like to create your own star chart. And I'm facing to the south, as is my star chart. This yellow line is the ecliptic, the path which the sun will take across the sky. Speaking of the sun, it's outputting radio emissions, and those radio photons are in a frequency of 2,800 megahertz, 2,800 megahertz, and the amplitude of that is 10.7 centimeters. And the 10.7 centimeter radio flux is only at 73. So the F107, the 10.7 centimeter radio flux, or perhaps you prefer to refer to it as the 2,800 megahertz radio flux, 73 solar flux units. Here is the radio flux in context. The 1-year chart is this black line. The red line underneath it is the sunspot number. And the blue line down here is the Potsdam AP, the interplanetary magnetic field. So we are expecting a geomagnetic storm. Late in the day today is the official NOAA forecast. And we've already got a weak diffuse coronal hole wind stream has arrived. So that will represent an additional intensification, most likely, of that coronal hole wind stream. We'll show you the solar wind data in a minute. First, global seismicity. We are seeing a continued earthquake drought for 7 magnitude earthquakes. Earthquake droughts end in large earthquakes. So if you're in an earthquake-prone zone, please be prepared. And we love this chart on volcanodiscovery.com. The 90-day bar graph of large earthquakes. You can also visit this page, which will allow you to sort by magnitude, a fantastic tool. There are all the 4 magnitude quakes. There are the 5 magnitude quakes. So we saw about a half dozen 5 magnitude quakes here over the past 24 hours. Let's go to the USGS site and roll up the list. So no major quakes. There was a deep one in the Band A Sea. It was only a 4.6 magnitude at 159 kilometers depth, though. And if that was at the surface, that would be like a 5.2 magnitude. Also a very shallow quake here at Hawaii. It is at a depth of 1,200 meters above sea level. So, and this is over the sea. So it's over the Pacific Ocean, folks. How an earthquake occurred at 1,200 meters above the Pacific Ocean. We'll have to save that for a later episode. There is a reason why that happens. It's not magic. It's not a spaceship. It's not Nibiru. It has to do with the way that the location of earthquakes are calculated. I won't get into it. It's really not worth it. We've seen many shallow quakes at Hawaii, most of them under the largest volcano in the world, Mauna Loa. Iran saw a 5.4 magnitude quake. That probably did some damage. As we see, the shake map is shown here in yellow. Also a deep quake here north of New Zealand, near Tonga, north of the Tongan Trench, north of the Kermadec Trench, one of the earthquake hotspots on Earth. Also some aftershocks there in Iran, a deep quake at Chile at a 4.9 magnitude, 123 kilometers depth, and a deep quake under southern Alaska as well. Check it out. Shivaluch has grown another dome. It's Dolphin 2. And I think it might be one of these two structures right here. Don't quote me on it. I really don't know for sure, but Shivaluch has grown a new lava dome. So magma's been oozing out at a very steady flow rate without exceeding the limits of plastic deformation of the erupted viscous lava. Cheers. Mount Abico also erupting, 11,000-foot ash plume above it. Subanose Jima, 6,000-foot ash plume there. Mount Ibu, flight level 070. Semeru, producing a 14,000-foot ash plume. Dacono exploding. 7,000-foot ash plume there. Pacaya. Looks like an uptick at Pacaya down in Guatemala. Pacaya now producing a 10,000-foot ash plume. Please don't hang glide over the caldera. Fuego in Guatemala exploding. Near constant incandescence continues to be observed from the summit crater and caused glowing avalanches of material toward Seca, Sanitza, Taniluya, Trinidad, Las Layas, and Honda ravines. Lahars, known as mudflows, could occur if heavy rainfalls remobilize the fresh ash deposits. Sangay in Ecuador also exploding. 21,000-foot ash plume there. Looks like a worldwide volcanic uptick here, folks. Revenador also exploding. 14,000-foot ash plume there. Sabancaya, an uptick at Sabancaya. It's now a 27,000-foot ash plume above it. And Nevados de Chilean still exploding, still producing a 13,000-foot ash plume, still reminding us to not pole vault the caldera. If you should come up with the idea of pole vaulting the caldera, please take video of it. Just kidding, folks. Don't pole vault the caldera. This public service message brought to you by smAsho.com. No major solar flares over the past 24 hours, although we did see a minor B-class intensification, which we probably showed you, and will probably show you again in some other emission spectra. Here's the proton flux. No spikes in it, and we're not really expecting a strike in this either. The coronal mass ejection, I don't think will be capable of producing what we'd call a proton event. Here's the GOES magnetometer over the past 3 days, and we're seeing a little higher highs and higher lows from the GOES magnetometer. And here's a solar cycle comparison. So we haven't shown this for a while, and you can see cycle 25 is right in line with cycle 24, pretty much at the same point now that cycle 24 was at. Although I don't think this was updated because we're well past 10 months after the cycle start. So you can find other charts about this at solon.info. For example, comparison of solar cycles 12, 14, 24, and 25. Here's an overlapping one. So this one was updated on May 1st, according to solon.info, and you can see the green line there is cycle 25. The black line is cycle 24. So almost at the same point in terms of sunspot number only, folks. Now we're looking at the sun, the heliospheric current sheet. This is stereo A, this is stereo B, and Earth is solidly in a South Pole-oriented current sheet, the heliospheric current sheet. Here's another view of the same data from the line of sight perspective. And we do see a big dip in the B field here. You see how this line is coming way down, this blue line, coming way down toward the south, an indication that the North Pole current sheet is probably on the way. We've got some activity rising as well. We'll show you a quick little clip of that toward the end of the daily space weather. Here's the line of sight coronal hole plot, and you can see coronal hole associated with the South Pole here rotating into the Earth-facing zone. We can expect a coronal hole wind stream from that in a few days, probably about 3 days. So here are the coronal holes from Integrated Space Weather Analysis. Here are the sunspots and the magnetogram. Again, only one sunspot right now. Here are the detected filaments, some of which appear to be most likely collapsing on the Earth-facing side and erupting on the far side. Here's the planetary K index, the KP index currently at 2, as the currently streaming coronal hole wind stream that's arriving, that's already here, is pretty weak and pretty diffuse. It's not fast and it's not dense. It's slow and diffuse. So it only reached a peak of about 423 kilometers a second here, folks, and the density spike only got up to about barely over 10. It looks like it made it to about 15 protons per cubic centimeter. And here's the standard signature of a coronal hole wind stream. You can see the density drops off at the same time that the velocity goes up. Also, the temperature usually changes around that same point. That's this green line here on the bottom. So it's a weak coronal hole wind stream. We're awaiting the coronal mass ejection strike in the next 24 to 36 hours. And we could make it up to a KP of 6 or something like that. That would be my guess, would be a KP of 6. So another geomagnetic storm is indeed in the forecast. NOAA and I agree on this one. So here's the magnetohydrodynamic pressure currently in the geospace. It's 4 hours of data if all goes well. And we see actually most of the pressure here in the magnetotail region on the far side of the sun instead of on the on the non-sun side of the Earth as opposed to the sun side of the Earth. And here are ground magnetic perturbations. It looks like we've got missing data here. Actually, that's not 4 hours of data, folks. It's only like an hour and a half of data. It normally shows 4, not sure why it's showing less. And if your theory is that it's because of Nibiru, please leave us a comment. Let us know. We're very concerned about Nibiru. Pardon my sarcasm. So there are the ground magnetic perturbations over the past hour and a half. Nothing too extreme going on. We're not expecting major auroras from this weak diffuse coronal hole wind stream. Although we are expecting some when the coronal mass ejection arrives. So let's welcome Twitch. Welcome back, Twitch. This is our cosmology segment. We'll integrate this one into the daily space weather. But for you over there at Twitch, here you go. It's our live stream. First of all, thanks to everybody who subscribed over at YouTube. If you're new, press like and subscribe. Share the content with your friends and foes, your science noobs and your science pros, and your people on your social media. Let us know in the comments what your favorite social media is. We're also on BitChute, by the way. We've got an exclusive that we just put up on BitChute. Our meteorology segment is currently only on BitChute. BitChute.com/smAshomash. Visit our own website, smAshomash.com, smAshomash.org. We'll redirect you. Click on our link for our smAsho merch, and you'll see this fantastic shop. The products are very high quality. Perhaps pick up some merch. And let's get into today's cosmology segment. First of all, the astronomy picture of the day from apod.nasa.gov. It's Galaxy 4565, part of the New General Catalog. Most likely a radio galaxy, a great example of a galaxy viewed edge-on. If we viewed this from a different perspective, it could look like a spiral. Who really knows? As the spiral arms, if there are any, are in the way. But a great view there from the Hubble, perhaps. Let's see. Is it from the Hubble? I have no idea what it's from. It's from CFHT. Okay. Anyway, great shot of NGC 4565. Here is an image from the Hubble. It's a deep field image showing various different galaxy shapes. Stretched out spirals, confined spirals, irregular spirals, merging galaxies, elliptical galaxies, and all kinds of other funky galactic shapes. I'll scroll around for your viewing pleasure. Before I reveal the article from whence it came. I like this galactic merger that looks like it's going on up here, this long string. Very nice. Some great three-dimensional looking perspectives of some of the structures of these spiral arms and dust lanes in the internals of these galaxies. Great, great visuals there. Another merging pair of galaxies there in the upper left, it looks like. Another fantastic deep field image from the Hubble Space Telescope. And when the Hubble Space Telescope first went up, folks, we were absolutely astounded. We did not realize how complex deep space really is. Great series of elliptical galaxies there. Three of them right in a line. Anyway, this article is from SciTech Daily. One of the best science publications in the world. So perhaps check that out. Let's pick a random number and look at another object. Today's random number is 378, which coincides with something at the Neil Gorell Swift-Bat X-ray Observatory. 378 is Nova Mus 1991, a low-mass X-ray binary / massive radio source believed to be a black hole. Here are the X-ray transient outputs from that, and we'll take a look at it visually here at the Smash News Network. We like to give people perspective. So let's go to Aladdin Light here, and we'll take a look at this in X-ray. And it's not showing up on the XMM Newton or the Chandra. All right, let's take a look at it in, does it emit ultraviolet light? It is a binary, perhaps it does. Let's take a look at it on the Galix. There it is in UV, and there's nothing to see. How about in infrared? And there it is on the 2-mass. It's a very weak infrared signal there. This low-mass X-ray binary / black hole. And I believe the default view is the DDS. So there it is. It's actually quite an oblong-shaped thing there. It's the crosshair is on this object, and it is irregular in shape. So perhaps that is one for future study. Nova Mus 1991. Leave us a comment if you find an article about that one. There it is on the SIMBAD, and you can see it is indeed an oblong-looking light source. I'll just say the low-mass X-ray binary, entry number 378. At the Neil Gorell Swift Observatory. That's today's cosmology segment. See you later, Twitch. We'll continue with the daily space weather. Here at the Smash News Network, least busted name in news. Here's a diagram of Earth's Van Allen belts. Feel free to pause the video. Here is a 1-year chart of the electron flux surrounding planet Earth measured at the ionosphere layer. Here's a 3-day chart of the electron flux. And we're wondering where the electrons are. Well, it's because the coronal hole wind stream has arrived and depleted them. It's like a proton light event. I won't get into it any more than saying that. We don't see any charging hazards. We see low levels of electron flux. And the uptick in the electron flux never came. So Noah and I were both incorrect on that forecast. It's a rarity, but there it is. Here's the forecast. We're expecting a continued dip in the electron flux here and then an increase. I don't know. I'm not going to conjecture on that. We'll just have to keep an eye on it. Get it? Ion? Yeah. Anyway, here's the total electron content forecast. This is the entire air column, essentially through both Van Allen belts. And we were seeing chaotic bands of electrons once again. You could expect to see GPS errors even at nighttime around the equator. As you can see, places like Africa, the Central Atlantic Ocean, and South America all experiencing GPS errors at nighttime. Here's another diagram of the atmosphere. And we're showing you this to show you where the F layer is, the F ionosphere at 300 kilometers. And now we're showing the ionosphere. And keep in mind, folks, if you're a regular viewer, we've changed up the format of this once again. So now we're showing 2 hours per second, and we're showing 2 days of ionospheric behavior. I think this might be the best format for this resolution, because the resolution of this map, this ionogram, is only 1 megahertz, which is 1,000,000 vibrations per second. And I think this may be what we stick with when we show the ionosphere maps daily, because the resolution is so low on the map. So if you've got an opinion on this, let us know in the comments. I think this is probably the best data set we can show in the context of these videos. So here is the latest image. That is 9:30 Universal Time. And normally we do have the map centered on the prime meridian. So if you think it looks weird, it's because I had it centered on 180 degrees instead of 0 degrees longitude. If you didn't check out our meteorology segment, today's meteorology segment is separate from the daily space weather. So you'll have to check that out separately. We're moving straight into bonus features today. Here at the Smash News Network, Least Busted. Name and news. So here are the bonus features in the form of the most recent hydrogen alpha imagery from Udaipur, India. There are the latest images from the ground-based solar observatory, and it looks like there's a bunch of missing data and clouds. Next, I'd like to thank our patrons, the true source of funding for the content. Please consider becoming a patron at patreon.com/smashamash. Thanks, patrons, for increasing the probability that we'll reach our goals for 2021 and continue making these videos publicly visible and existent. Thanks for helping us remain existent, patrons. It helps a lot. Here comes some more bonus features. It's the solar intensity gram and the freshly updated colorized magnetogram. So here's sunspot 2822. It's looking stable here over the past 24. In fact, I think it actually grew a little bit since yesterday. It's still alpha class as it only has one umbra, North Pole shown there in blue. And otherwise, we've got no sunspots. So this active region rising over here, look, we're getting a glimpse of it already. And it's probably way too early to see any umbrae. We can barely see fields. And indeed, we don't see any changes there on the intensity gram, but indeed we see that rising. It looks like a sunspot to me, as we see very large magnetic fields being shown by the location of the plasma here. It's a bunch of gaseous, very, very hot iron orienting to those magnetic fields. Fantastic view of that rising region, most likely a sunspot, I would guess. And before we close things out, one last thing, folks. Why is it that carbon looks so differently on the surface of the sun than iron? So here's iron. It's ionized iron. And here's ionized carbon. Why do they look so differently? And what do you think the different chemical signatures on the surface of the sun are telling us about cosmology, astrophysics, and more? Let us know in the comments. Thanks for tuning in. Brace yourself for a geomagnetic storm. There's another one on the way. Visit our links. Support our channel. And we'll see you next time at the Daily Space Weather. May that solar wind be at your back.